we are discussing about the measurements of 2D figures. We have done the 2D figures with the linear sides. Now there are few figures whose sides are non-linear. For example, if you take the circle, it is a non-linear edge. If you take the triangle, there are 3 linear edges. So here in the mensuration, the other part of 2-dimensional figures are non-linear edges. Let us start with the circle. What is a circle? By listening to the word circle, immediately we get a picture in our mind like it is bangle. Then what are the things can be denoted in the circle? There is exactly at the center point, which is called center of the circle. And one more thing is, from the center to any point on this edge, this distance is going to be radius. Usually it is denoted by r. Actually the circle is not this interior part and not this exterior part. This thin line, round line is called circle. So for a circle, there are the dimensions only radius and it is a center and radius. With the help of only the radius, we can find other measures of this circle. If this radius is some c and this end is a, c is a radius, if you extend this radius other side, say this is b, now this total AB is called the diameter. So AB is diameter and half of the diameter, usually diameter is denoted by d, and half of the diameter is radius. Radius is either CA or BC. Is radius which is exactly half of the diameter. These are the dimensions of a circle. With the help of these dimensions, we can find out other measure. What will be the other measures of a circle? For a circle, the one measure is area. How can we calculate area of the circle? For that we need the radius. If diameter is given, take half of the diameter, and area is given by pi r square. Pi times of square of the radius, pi r square. We know what is the pi value. It is nothing but 22/7, or it is 3.14 approximately. Usually we don't use the decimal value of the pi. Take 22/7, that gives easy calculation. And this area means this complete region, how much area is covered. And the other thing is the perimeter. What is the perimeter? Starting from any point of the circle, this complete length of the edge line here to here, this is called perimeter, or we can say circumference also. So other measure is perimeter. This also called circumference. This is given by 2 pi r. To remember the area and perimeter of a circle, for mathematical background students, it is very easy. There is a mathematical relation between pi r square and 2 pi r. If you differentiate pi r square, you will be getting 2 pi r. If you integrate 2 pi r, you will be getting area. So for mathematics background students who knows the differentiation, integration, remembering only one formula is more than enough to work out other area. If area is pi r square, just differentiate it, you will be getting 2 pi r. So just memorizing the area, you can find out the perimeter or circumference. This about the circle, and we'll see few things in circles, that is according to the angle concepts. In a circle, this is the center, and this part I am taking A to B, this is arc. Join the center CA and CB. This is the minor arc, which is the smallest, and this is the major arc. On the major arc, take any one point anywhere. Now join, say this is some P. AB is a minor arc, and in this direction AB is going to be major arc. You are taking a point P on the major arc and join AP and PB here certain angle is formed and here also certain angle is formed. So note that this very important concept in any competitive examination. This angle whatever it is formed, this is always half of this angle, or else this angle is double of this. If this is some theta, this is going to be 2 theta. This very important concept we need to remember in the circle. Based on this concept, the questions are asking. And sector. How the sector is formed? It is nothing but a part of the circle which is included the center. This is a circle and CA is the radius. Take any point on the circle anywhere on other part of the circumference or perimeter. Here I am taking another point B. Join CB. This region is called sector. Here CA and CB are the radius of the circle, means if this is radius R and this also radius R, and AB is the arc. AB is arc. It is the curved line, that's why we are taking like this. AB is arc. Let the length be some L, length of the arc, and radius is CA or CB, which is radius denoted by R. Now we need to find the area and circumference or perimeter of the sector. Here some angle also we find, that is angle subtended by the arc AB at the center. Say this is some theta, and there is a relation between the angle, the radius and length of the arc L. Out of these three, if any two are known, we can find out other by using the relation L is equal to R theta. But this very important theta should be in terms of radian. If L and R are in centimeter, in meter, whatever it may be, but theta should be in radian. Theta should be in terms of radian. Sometimes the theta value will be given in angle. We need to convert into radian to apply the relation between L, R and theta. Now coming to measures of the sector, area of sector. The area of sector is nothing but this angle by 360 into area of the circle, means theta by 360 times of area of the circle, which is pi r square. If you remember area of the circle, then area of the circle of theta by 360 gives area of the sector and perimeter. Perimeter is nothing but go around the length of all boundaries. If we observe here, this is the length R and this is the length R and this is the L. So adding all the boundary lengths, we get the perimeter. So that is R plus one more CB, that is R, and plus this arc length L. So R plus R, 2R plus L is the perimeter of the sector. This is all about the 2D figures. In the 2D figures, we discuss about all the diagrams which frequently asked in the real-time examinations, and let us know something about the 3D figures. "3D is nothing but it is a solid. We can call them solids. Then what are the solids? In our daily life, we'll come across with many different type of solids, like cube, cuboid, cylinder, like this cone. These all are called 3D figures or the solids. Let us start with the cube. What is cube? Cube is nothing but it 6 faced equal edges. You can visualize this figure. It has 6 faces and every face is in the shape of a square. It has 6 faces and 8 edges, 8 corners, vertices and 12 edges. It is a square and every edge length is going to be same. If we take S is the length of an edge, every edge is same units, equal measure of every edge. This is a cube. For a solid there are 3 types of different measures. In case of it is a 2D figure, we find only area and perimeter, but in case of it is a solid, there are 3 different type of measures. One is the lateral surface area, second is total surface area, and other is the volume. Let us see what are these 3 different dimensions. Let us start with the lateral surface area. This is also called curved surface area, or what is meant by this lateral surface area or curved surface area? For any solid, say for example this is a solid, for this the lateral surface area is going to be, excluding top and bottom, this round whatever the area covered, this face, backside face and this side face, this total surfaces area is called lateral surface area. Even for a cube, when you hold like this, excluding the top and bottom, the other curved area is called lateral surface area. Looking at the figure, we are going to find the area. If you exclude the top and bottom, how many squares are around? Here front one face, back side one face, and left side one face, right side one face, like that. Total 4 sides are there. Each side is given by a square. So adding up all the 4 areas of 4 squares, you will be getting the curved surface area. If you take one square, which is front view, this is a square. Area of the square, we know it is side into side, so that is S square. Area of one face is S square. Like that, we are having 4 sides, means 4 views around, means 4 squares. So 4 into S square is going to be curved surface area. And total surface area. Total surface area is nothing but the lateral surface area plus top area plus bottom area. Together it is called total surface area. Here total we have 6 faces, around 4 faces, and top is one face, bottom is one face. Then each face is in the shape of a square. So one square's area is S square. Like that, we have 6 in all. So 6 S square is going to be total surface area. And what about the volume? For 3-dimensional figure, volume is nothing but this length into breadth into height, but each dimension is same. So S into S into S is going to be S into S into S, which is equal to S cube, is going to be volume. These areas are measured in terms of square units and volume is measured in terms of cubic units. This is very important. This is the square units and this is cubic units. This is square units since it is area. This is area, this is area, that's why in square units. Since it is a volume, the measures are cubic units. In the real-time exam, by finding these terms, cubic units indicates volume and square units indicates area. This about the cube. Sometimes in the cube, we may require the length of the diagonal. Here, what is going to be the length of the diagonal? It has total 8 corners. In 8 corners, if we take, this is one corner, its opposite corner is going to be this corner. The distance between these 2 opposite corners is the diagonal. For example, if we take this corner, if its opposite corner is going to be this, the distance between these 2 corners is going to be the diagonal. Then how can we find the diagonal? This is very important concept. Diagonal of a cube is, that is square root of s square plus s square plus s square. Which is going to be 3s square, it is nothing but root 3s units, since it is the length. It is diagonal of a cube. This all about the cube. We need to remember the formula: surface area, that is lateral surface area, and total surface area, and volume is given by s cube. Wherever we require diagonal, that is root 3s, you can calculate by using this. The diagonal of cube or cuboid, whatever it may be, the diagonal is going to be one corner to its opposite corner, the complete length. It is measured as length square plus breadth square plus height square under root. Since the length, breadth, heights are same in case of a cube, that's why it is s square plus s square is square. It is 3s square. When the separate root, so root 3 into root s square going to be s, so root 3s is a diagonal. Our next figure is cuboid. What is the difference between cube and cuboid? In cube, all the dimensions are same, but in cuboid, we find the different dimensions. It is just like a box. The best example is matchbox for a cuboid, or the wooden box we see in our home, like suitcase like this. This is a cuboid. What is the difference between cuboid and cube? In cube, all the edges are with equal measures, but here the different measures. Out of these three different edges, one we take length, and one we take as breadth, and other we take as height. So we call length, breadth and height. There are three different measures of a cuboid. Now for this any three dimensional figure, we need to know the areas and the volumes. Then what about the lateral surface area? Lateral surface area is given by 2 into 2h into L plus B is given by the lateral surface area, and the total surface area is 2 into LB plus BH plus LH gives the total surface area. Even it is nothing but the lateral surface area is excluding the top and bottom. The total 4 faces area is 2h into L plus B, and here the top area and base area is included. That's why it has become 2 into LB plus BH plus LH. It is the total surface area. And what about the volume? As we know, the length into breadth into height is giving the volume. So volume is nothing but length into breadth into height, or simply you can write LBH, cubic units, since it is volume. And what about the diagonal of a cube? The diagonal of a cube, as we know, it is nothing but square root of the sum of the squares of all the three dimensions, which is L square plus B square plus H square, is for the cuboid. So for cuboid, these are the three dimensions by using this formula. And the next solid is going to be cylinder. By hearing to the word cylinder, what is flashed in our mind? Cylinder shape. It is like a pillar, rounded pillar, or any shaped based pillar. Usually the cylinder is nothing but we get an idea by listening to the word. This is the shape of the cylinder. What we notice in the cylinder, here the base and the top with the same shapes, it is nothing but circle. There is a circle on the top, the same circle is at the bottom, and this is going to be height. Let us see what are the dimensions of this cylinder. Since it is a circle, there is a center, and this center to the edge of the circle is radius, which we take r, and here this is height denoted by h. For a cylinder, we have two dimensions. One is the base radius, you can call this as base radius also, base or top, base radius and the height. What about the measures? The first measure is lateral surface area, we write LSA, or curved surface area, both are same CSA. As we have seen, lateral surface area and curved surface area both are same. To find out the lateral surface area is nothing but the base perimeter into height. Find out the perimeter of the base and multiply it by height. It is 2 pi r is the base perimeter into height, square units. And the total surface area. What is the total surface area? The lateral surface area plus top area plus bottom area. The lateral surface area is 2 pi rh plus, since the base is in the shape of a circle, one circle on the top and one circle at the bottom, so pi r square plus pi r square, it is going to be 2 pi r square. By doing a little bit math in it, by taking 2 pi common, 2 pi r common, we get h plus r. This is going to be total surface area. And what about the volume? Volume is nothing but for any solid, regular solid, the base area into height gives the volume. The base is in the form of a square. Area of the square is pi r square multiplied by height. So pi r square h is going to be volume. These are in square units since area, and this is going to be cubic units. This is all about the cylinder. And let us take another solid, cone. What is the shape of the cone? This is shape of the cone. What are the dimensions of this cone? The base is in the form of a circle, so there we have a base radius. Let us take r, it is the base radius. And there are two heights for this cone. One is the vertical height, that is from vertex to the center of the base circle. This is called vertical height. Say h. H is vertical height. And there is another height, it is slant, inclined. This length is denoted by some L. L is slant height. For a cone there are two heights, slant height and vertical height. If we observe this figure, this length is r units, it is a vertical height, it is a slant height. Here this is forming a right angle triangle. This figure, dotted figure, is forming a right angle triangle. As we know, there is a relation between three sides of a right angle triangle. Since there is 90 degrees, this slant height is going to be the hypotenuse, and this side 1 and side 2. As we know, according to Pythagoras theorem, the longest side of right angle triangle square is going to be equal to the sum of the squares of other two sides. So then there is a relation between L, H and R is given by L square plus H square plus R square. By using this relation, whenever we necessary, when two dimensions are given, we can find out other dimension. This is very important relation between the slant height, vertical height and the base radius. This is all about the dimensions. Then what about the other measures? Lateral surface area and total surface area and the volume. The lateral surface area is nothing but, for that we need to know the radius and the slant height. It is given by pi RL. Is the lateral surface area or curved surface area. And what about the total surface area? We know that curved surface area plus bottom area, together it is going to be the total surface area. As we know, the lateral surface area is pi r L, and the bottom is in the shape of a square. Area of the square is pi r square. Doing little bit math, pi r is common in both, then L plus r. Since it is a surface area that expressed in square units, even this is area, it is in square units. And the volume. Volume is nothing but 1/3 of the volume of the cylinder. What is the volume of the cylinder? We have seen just now, it is pi r square h. So 1/3 of pi r square h is going to be the volume of the cone. From this we need to understand, from a cylinder, regular cylinder, we can form 3 equal volumes of the cones. That's why it is given 1/3 of the pi r square h. Pi r square h is the total volume of the cylinder. This 1/3 means 3 equal cones. Equal in the sense the base radius and the vertical height are equal. We can carve 3 equal cones whose base radius is equal to the radius of the cylinder. At the same time, height of the cone is equal to the height of the cylinder. So this is all about the cone. And coming to other solid, sphere. What is a sphere? It is just like football, volleyball is a sphere. For the sphere, it is not a circle. There is a big difference between the sphere and circle. Sphere is a solid, circle is a 2D figure. So even for the sphere, this is the base radius. The radius is nothing but from center of the sphere to any point on the surface area of the sphere. So it is the radius of the sphere. We have only one dimension, that is radius of the sphere. And what about the surface area? It doesn't have the top and base. That's why we cannot define the lateral surface area and total surface area. Whatever it may be, both are same, since there is no top and there is no bottom. So the sphere has only one surface area, that we call just a surface area, or total surface area, or lateral surface area. So we take only the surface area. Then what is the surface area of the sphere? The surface area of the sphere is nothing but 4 times of the circle area. Circle area is pi r square, as we know, then 4 times of it, it is 4 pi r square. So it is very simple to remember, surface area of the sphere is 4 times of the circle. Just knowing the surface area of the circle, then multiplied by 4, you are getting the surface area of the sphere. It is in square units. And what about the volume? Here the volume is 4/3 pi r cube. 4/3 pi r cube, cubic units is the volume. And if you have little bit idea about the calculus, the differential integral, there is a mathematical relation between these two. If you remember the volume of the sphere, you can find out surface area very easily. Just differentiate this with respect to r, 4/3 pi r cube. Differentiation with respect to r gives 4 pi r square, or else just you integrate the surface area, you will be getting the volume. So remembering one, either surface area or the volume, you can find out other. If surface area is known, just integrating it, you will get the volume. By differentiating the volume, you will get the surface area. So knowing one is more than enough to work out the other measure of this sphere. And coming to other solid, it is hemisphere. Hemi is half, means half of the sphere. We can call it as semisphere also. Semisphere or hemisphere, both are same. Exactly half of the sphere is hemisphere. Here the dimensions are, this is R and this also going to be R. It is about the hemisphere. R is a radius, and we see the measures. The lateral surface area, since it has the base also, so we have the lateral surface area and total surface area also. The lateral surface area or curved surface area is given by, here excluding this bottom, the entire curved region is called lateral surface area. It is going to be exactly half of the surface area of the sphere. What is the surface area of the sphere? It is nothing but 4 times of area of the circle that we have seen, 4 pi r square. Half of that is 2 pi r square. So lateral surface area is 2 pi r square units. And the total surface area. For the total surface area, the total curved entire lateral surface area plus base area together gives the total surface area. The lateral surface area is 2 pi r square, and the base, which is in the form of a circle, area of the circle is pi r square. Together it is giving 3 pi r square units. It is the total surface area of the hemisphere. And the volume, exactly half of the volume of the sphere. As we know, volume of the sphere is 4 by 3 pi r cube. Half of that is going to be 2 by 3 pi r cube. This is about the hemisphere. So we have seen all the properties and the dimensions, measures of 2D and 3D. Based on this, we are going to solve few problems.